Okay, in this video I'm going to show an example of some time division multiplexing. And in this example we've got 12 input signals, each with a data rate of 2 megabits per second. Frames are constructed using byte-wise interleaving, and there are 2 framing bits per frame. And so it asks you to make a sketch of the situation, calculate the size of the output frame, the frame rate, frame duration, the output data rate, that is the multiplexed data rate, and the percent of the frame that is input sources. And so I'll start by drawing the picture here. We have 12 input channels, and these input channels are each at a rate of 2.0 megabits per second. I'll call that rate 1, R1, R1, dot, 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 R1, where R1 is 2 megabits per second. I'll multiplex them together, and I'll make a frame here. I'll draw a frame. We have byte-wise interleaving and 2 framing bits per frame. So I've got 8 bits from channel 1. I've got another 8 bits from channel 2, and finally channel 12. 8 bits, dot, dot, dot. 8 bits from channel 12, and finally 2 framing bits. Okay, so the total, so there's a picture of it. And the output frame, the size of the output frame, the number of bits in the frame is little n times big N, little n being 8 bits per channel per frame, big N being 12 channels. Okay, and the total number in the frame is the 8 times the 12 plus the number of framing bits. And here we have 8 times 12 plus 2. 8 times 12 is 80 plus 16. 96 plus 2 is 98 bits per frame. Okay. The output frame rate. What I'm going to do here is use the following equation, or the following principle, that the time it takes to create a frame, here is my frame, and it has NF bits in it. The time needed to create that frame is exactly the same as the amount of time it takes for one of the sources to fill up the bits in that frame. And so the time needed to create this frame is 8 times, or let's say 8n times, the period, the bit period of one of the inputs. Okay, so this is the amount of time it takes this first signal, let's say, to send 1 bit, and n is 8 bits per frame, and so we're going to take 8 times the bit period of this source is the time needed to create this frame. And so the frame rate is 1 over that, which is 1 over n times t1. But the period of one of these signals here is the inverse of its rate. So if I want to put this in terms of its rate, R1, just take it to the numerator, over n. Okay, and this is now 2 megabits per second all over 8, or 250 kilobits per second, which is 1/4 of a megabit per second, or 2/8 of a megabit per second. So I get 2/8 of a meg, 1/4 of a meg, which is 250 kilo. Okay. Okay, so we just calculated the frame rate, but we got that starting with the frame period. And so we have that frame period here. TF is n times T1, but we don't have T1, we have R1, the rate. So this is going to be n over R1, which is 8 over 2 megabits per second, which is 4 times 10 to the minus 6 seconds, or 4 microseconds. Okay, and at this point in the semester, I'm assuming you're pretty familiar with taking 8 over 2 megs and turning that into 4 micros. Okay, meg is 10 to the plus 6, and when we bring it up, it becomes 10 to the minus 6. 8 over 2 is 4, and so this is 4 microseconds. Is the duration of one output frame. The output data rate, this is, so the total, or the multiplexed data rate, is given by knowing the number of bits in a frame and the time for one frame. So the number of bits in one frame per the time in the frame needed to send the frame. So rate is bits per second, and we have the number of bits in a frame sent in the amount of seconds it takes to send a frame. So this gives us the total rate, and the number of bits in a frame was 98, and the time for one frame was 4 microseconds. And so this is, let's see, 100 is 25 times 4, so this is 24.5. And then micro in the denominator becomes 10 to the 6th in the numerator, or 24.5 megabits per second for this example. Okay? Finally, the percent of the frame that is data bits from input sources. And this is easy to calculate. Percent from input is, well, 96 of those bits are from input sources, and 2 of the 98 are not, and so 96/98. And if you want that as a percentage, I suppose I can calculate it on my calculator. 96 divided by 98 is 0.979, so 98, let's just say 98%. Okay, well, I hope that helps on this problem, and thanks for listening.